Uh, Good evening, Shamim ma'am. Good evening, Samsad ma'am.
Ma'am, good evening, Ponviji ma'am.
Ah, Good evening, ma'am. We'll start
Ma'am,
by 6 o'clock, ma'am.
yeah, sure, ma'am.
Yeah.
Okay, ma'am.
Uh, the students will be joining by that time. No issues.
Okay, ma'am.
Hi, Shamim. Can you hear me?
Yes,
Uh,
ma'am. Yes, ma'am. We'll start by
okay, okay.
6. Okay.
Yeah, just testing.
Yeah, thank you.
Shamim ma'am, we can start, ma'am.
Yeah, sure, ma'am. Just a
Yeah,
minute.
I have made the resource person as a co-host. She can also share her slide.
Yeah, okay, ma'am. Okay, ma'am. Thank you.
Thank you, ma'am. Yeah.
Thank you, ma'am. Just 2 minutes, ma'am.
Okay, ma'am.
Shall we start, ma'am?
Yeah, ma'am.
Okay. Good evening, dear all. Good evening to our resource person, Dr. Shamshad, ma'am, and Dr. Ponvaji, ma'am, our area coordinator. It gives me immense pleasure to introduce our distinguished resource person for today's session. She is Dr. Samsad Beagum. She will be delivering a talk on building a career in robotics, getting started with ROS. Dr. Shamshad, ma'am, is it audible?
Yes, Shami.
Yeah, let me continue 2 minutes. Okay, thank you. Dr. Shamshad Beagum is currently working as an assistant principal engineer at ST Engineering Singapore, where she contributes to the development of advanced robotic and intelligent systems. She possesses rich expertise in robotics, robot operating system, artificial intelligence, autonomous systems, machine learning, computer vision, embedded systems, and intelligent automation. Actually, what makes today's introduction particularly special for me is that Dr. Shamshad is not only a respected professional colleague, but also my dear sister. I had the privilege of working with her for nearly 8 years at Taif University, Saudi Arabia, during which I witnessed her unwavering commitment to academic excellence, research, innovation, and student mentoring. Throughout her career, she has consistently demonstrated exceptional technical competence and a deep passion for emerging technologies. Her ability to bridge the theoretical concepts with practical engineering applications had really enabled many students and young researchers to pursue a successful careers in robotics and intelligent systems. She has been actively involved in multidisciplinary research, project development, curriculum enhancement, and mentoring aspiring students in cutting edge domains. Dr. Shamshad's strength lies not only in her technical expertise, but also in her ability to inspire and guide learners. Her extensive experience in academia and industry gives her a unique perspective actually on the skills, the knowledge, and the mindset required to thrive in this rapidly evolving field of robotics. Today, she'll be sharing valuable insights into career opportunities in robotics and will provide us an introduction to ROS, the world's most widely adopted framework for robotic application development. I'm truly confident that her section will be highly informative, inspiring, and beneficial to all our students. Dear students, please join me in extending a warm welcome to Dr. Shamshad Beagum. Ma'am, it's an honor to have you with us today. On behalf of our department in RMK College of Engineering and Technology, we warmly welcome you and invite you to address the gathering now. Thank you. Over to Dr. Shamshad.
Thank you, Shamim.
Welcome.
Thank you for a warm welcome.
Thank you. Thank you.
Thank you.
Thank you.
A meeting after a long time.
Yes.
Okay. So I see only a few students. Should we wait or shall we start?
Viji ma'am?
Ma'am, we can start, ma'am. The students will be joining. No issues.
Okay.
Okay, ma'am.
Yeah.
So can you see my screen?
No, ma'am. Yeah, just now we were able to see.
Okay. Can
Now
see, right?
Now it's visible. I think
Okay,
it's
ma'am.
visible for all of us, ma'am. Thank you.
Okay.
By
Good
the way,
evening.
Shamsad ma'am, just a minute. I'd like to introduce Dr. Ponviji ma'am, a very good friend of mine. We are at Department of CSE at RMKCET now.
Oh,
Okay, and she's
nice to
okay.
e-meet. Yeah.
Okay.
Very nice to have you for this session, ma'am. Thank you
Thank
for
you.
joining us. We are
Okay,
eagerly
thank you for
waiting for your
inviting me.
session.
Yeah.
Yeah. Thank you, ma'am.
Okay,
Thank
thank
you.
you.
Yeah.
Thank you. Okay. Good evening, students. I'm Samsad Beagum, working as an assistant principal engineer in the Department of Automated System of Systems, Group Engineering Center, ST Engineering. Okay. So I think we are in an era of AI revolution, and it's really, I think it's really scary to see how the job markets change rapidly. So I'm also in a fear, just like you, how our roles are going to change. Okay, so the first of all, this talk has two sessions. One is a career guidance steps, and the next is a just getting started with a ROS. The first session, yeah, this is what I intend to do also, the career guidance. Okay, let's dive into some career guidance tips. So when you are searching for a job, you have to build evidence, not just knowledge. So your employer is not just looking at your knowledge; he is looking. They are looking at your evidence. So you should have some extra projects, internships, or some your own GitHub projects. Yeah, you can showcase them. So and you have to keep updated with the job market's reality. There are many opportunities, not just software engineer, backend, front end, DevOps engineer, cloud engineer, cybersecurity analyst, embedded software engineer, robotics engineer, systems engineer, technical consultant, solutions architect, ML engineer, data engineer, AI engineer. Okay, there are there are variations between an AI engineer, variations between an ML engineer and a data engineer. So go through the job requirements, find your passion, where you're passionate about, which field is most interesting to you. Go through the job requirements. Clearly go through the job requirements. What are the job requirements for an ML engineer? If I want to become an entry-level ML engineer, what are the job requirements? These requirements give you an insight into the tools that the industry actually uses and requires from you. Okay, so you must have knowledge about Git, Linux, Docker, cloud platforms, CI/CD concepts. For AI-related careers, you need to have knowledge on Python, PyTorch, LLM frameworks, MLOps concepts, and the Google's introduction to ML, I have given it as a link, is a wonderful introduction to machine learning. Yeah. And for cloud-related careers, you may need to have knowledge on containers, Kubernetes, AWS, Azure, Google Cloud Platform. Yeah. So go into the requirements, see what they require, and get your knowledge. Continue job hunting. It means that you shouldn't stop with some applications, few applications. I remember when I first tried in Singapore, it's like 250 applications. So you have to expect rejection. Rejection is part of the process. It is not necessarily a reflection of your ability. So even if it is marriage proposal or marriage application or whatever application, you have to expect rejection. It is part of the process. It's not your reflection of your ability. How should you proceed? You should customize your resumes for different roles. You choose few roles that you're confident and that you have passion, you are willing to learn and contribute. Customize your resumes and practice interviews regularly. Every interview is an experience. A key factor for a success is communication skill. You have to develop it. And we know some common ways of how to improve our language fluency. But what gives a better communication or a confident communication? Preparation. Prepare well. When you prepare well, when you're giving a presentation, when you're writing an email, you should be clear of what you're going to communicate. You prepare well, that gives you the confidence. When you get the confidence, it impacts your communication. And the basic art of communication is you have to be clear and concise in your communication. Make sure the listener understood what you communicated. When you're writing an email, first you should be clear what you're going to communicate, and after you send the email, ask them by call or an additional email or through another messaging mechanism to make sure the listener understood what you communicated. And when you are a listener or a receiver, make sure you understand what is being communicated. Do not leave any room for assumptions. So maybe he might the customer might have meant like that. No room for assumptions. You should again contact him, make clear whatever he has communicated to you. So this is a good skill of this is a good art of communication skill. Okay, think long time, not just salary. First job is important. More important are the skills and the experience we gain. So choose a role that accelerates your learning. Maybe it may be an internship, it may be a startup company with low salary, no problem. You choose the role, get trained, learn and train. Okay, so a high starting pay is maybe good, but it's not essential. As long as your job provides you learning and provides you skills, start your first job. Technical skills may get you shortlisted, but attitude gets you hired. Your positive attitude matters. So, what the employees look into you as a beginner, as a fresher, as a fresh graduate? Can this person learn quickly? Can they work with others? Can they take feedback? Can they be trusted with responsibilities? Will they contribute positively to the team? These are some of the things that matters most. Okay. So, to maintain a good attitude, what are the qualities that help? Self-awareness, emotional regulation, growth mindset, accountability, resilience. These are very, very important. This is a lesson that I have learned after a long this is a result of my experience. Okay, self-awareness. You must know the in and out of yourself, your strengths and weaknesses, how your actions affect others, how emotions affect you. Okay, what you know and what you do not know, when you need help and where you should improve. Know your reality, accept your reality, and improve. You should be self-aware. Then emotional regulation. This is very, very important. This is the ability to manage emotions constructively, especially under pressure. There are many articles and videos on emotional regulation. They guide you not only in your career, also in your life and also in your work-life balance. Growth mindset. You should have the belief that skills can be developed through effort and learning. So far, you have learned only the academic learning. So this is aimed towards gaining good grades, but this is the real learning starts from here. So you should have the belief, if I put effort and if I learn, I can develop the skill. I can contribute. This is the growth mindset. Then accountability. You have to take responsibility for the actions and the outcomes rather than blaming others. Finally, resilience. You may be rejected. You may have setbacks, failures in your projects you undertake. It's a fact. It's something that happens. Okay. But how quickly you recover from the failures, how quickly you recover effectively, how effectively you recover, that matters. So these are the qualities that help you to maintain good attitude. Finally, remember, every person, including your interviewer, has their own strengths and weaknesses. So this feeling gives you, I'm equal, I can learn, okay, an equality, or it will give you some confidence. Do not shy. You're not there to prove that you know everything. You are there to show that you have the basic skills, you can learn, you can work with others, and you can contribute positively to the team. Contribution is the key. So what you have to do, start job hunting now. Do not wait until your graduation. Do some projects outside coursework, do internships, gain practical experience, utilize AI tools. But understanding what you code, do not just rely on vibe coding. Understand what you code gives you the ability to evaluate the AI generated code. So if you ask me what is learning, I say learning is understanding. If you're what is expertise is understanding in simpler terms. If you can explain a complex concept in simpler terms, if you have understood, you have learned. Okay, so Understand whatever you write, even if the code is generated by an AI tool, understand it. And network with your colleagues and professionals. Networking is just like my network with Shamim gave me an opportunity today. Yeah. Okay. Now let's dive into with these introduction. Let's dive into the robotics software engineer requirements. So shall we continue, or are there any questions from the audience? Hello?
Students, you can raise your questions. You have a wonderful person with you today. Don't miss this opportunity.
Are you there, anyone? Or
Yeah, they'll be there.
uh,
Students, you can
can I
unmute
see
and
your videos?
Students, you can unmute your audio and raise up your
Can,
questions.
can I hear a few hellos from you?
Yeah, students, please.
Students,
She's
kindly interact, ma.
Can you introduce yourself, some of you?
yes, students. You can unmute your audio and you can speak a few words. She's waiting to hear from you.
Come on, Nilesh, Monish, Litika. Introduce yourself. Yoga Lakshmi. Actually, the problem is over here, ma'am. I saw your slide. Don't shy.
Okay.
Yeah, they feel a lot of, they have the shyness. And that is the greatest challenge we face with this, with our students, actually.
Just they can say a hi at least.
Yes.
Otherwise, I feel like I'm speaking to a wall.
Dear students.
Just, or you can type hi in the chat.
The chat box at least.
Okay.
Nilesh, you can say a hi even from your audio. Don't feel
Any
shy.
questions so far?
We are receiving hi. Unmute yourself and you can speak up.
Actually, now the Naharkoil irundhu. Sakkala.
But now she is speaking with you from
பேசலாம்.
Singapore. From see,
உங்களுக்கு என்ன கொஸ்டின் இதுல இருந்தாலும் சரி, பியாண்ட் இது இருந்தாலும் சரி, எனக்கு தெரிஞ்சிருந்தா I shall share with you. That's it. So
students,
shall we
come on,
continue?
pa.
Okay. Nilesh, Abhishek. Okay. Thank you. Thank you. Okay. How many of you are interested in robotics? Just say S. Just type S in the meeting chat.
Nilesh is speaking something, I think.
Nilesh, I couldn't hear you. Hello? இப்ப கேக்குது. சொல்லுங்க.
Am I audible? Yes, you're audible,
Yeah,
Nilesh.
கேக்குது. Yes, yes.
You can even type or speak up.
Okay.
Keklapa, Nilesh.
The management requested us to complete
Can you type, ma, Nilesh? Your voice is not audible.
Voice clear கேக்கலப்பா.
Yeah,
Nilesh,
Nilesh.
can you type the question in the chat, meeting chat? Okay. So, shall we continue? I think at least there are.
which domain
He has some question, but we are not able to hear him. Nilesh, can you please type?
Nilesh, I think the signal is weak at your end, ma. Nilesh, I think the signal is weak at your end. You just type your question, ma.
We have students from Tamil Nadu and Andhra too here in our batch.
Oh, okay. And that's nice. Okay. So I think I shall continue.
Yes.
I saw two S, so it's fine. Yeah, at least there are two listening ears. That would be really nice.
Yes.
Okay.
Okay.
So
Ma'am, am I audible?
Yeah.
yes, can you hear me?
Yeah, ma'am, I have a doubt.
Yeah.
Ma'am,
Introduce, ma.
currently,
Ah,
sorry, ma'am.
Introduce
Yeah, you
yourself that,
introduce yourself and then you ask,
then
ma.
start.
Yeah, ma'am, I'm Harini. I'm CSC
mm,
student.
mm,
So currently I've attended two or three internship and many companies. Ma'am, I have had many interviews. All the
mm.
internship where I went were like companies like networking companies who ask for what are the networks you have learned, can you implement in real world. None of the companies ask about full stack AI, anything. Like I have applied for the full stack AI ML kind of role, but they are calling me for networking kind of. Do you know this tool? Do you know this networking? How will you implement in this in real life? Is this more important that we have to learn networking now? Like we were focusing on full stack, AI, ML, deep learning, and so on. We never focused more on networking, but the companies are asking more in networking, ma'am. So can you tell whether it is booming now or what?
So, what kind of networking they ask you? I mean, can you do what kind of networking? It's like communication between two programs, or
No, ma'am, it's communication between servers and device 42. They especially ask for the device 42, which the tool they are using it for intercommunication, and also server to like they are a service provided to other industry like networking, connecting devices, computer service kind of, ma'am.
okay, okay. So maybe that is the company's requirement. Maybe I don't think so. Networking will be a requirement for if you're looking for ML engineer jobs. For ML engineer jobs, they just check your knowledge in machine learning algorithms. How can you create models and ML ops? For AI engineer, your ability to create agentic AI systems, yeah, coding with LLMs, integrating with LLMs, okay. So networking may not be of higher priority. Maybe the company is a requirement is I mean what they require is different. But I am I'm just surprised to see why. So when you apply, if you're interested in ML engineer, you have to when you apply for ML engineer, if they ask networking questions, yeah, that is something strange. So. So do not hesitate, keep applying. You can, yeah, that's
Okay,
my
ma'am. The
answer.
thing is,
Yeah,
I
yeah.
got many offer from networking company. I got two offer from a startup that is an networking company, but I'm searching for ML role, but I'm getting offers from only networking companies. So that I asked
Oh,
whether
okay, okay.
it's
I understand. I understand. I
booming or not.
understand. Okay, okay.
Yeah.
So this is the okay. So you are asking if networking is booming. No, this is the requirement of the company itself. Okay. So yeah, if you're passionate on ML, keep trying ML.
Oh,
When you're trying for ML, you just no need to focus on ML itself. You can focus on full stack engineer, front end engineer, back end engineer, or AI engineer. So these are all related to a step as a front end developer or a back end developer. Then get the experience for 1 year. Then jump into front end developer. Then full back end. Then full stack. Then slowly into machine learning. Yeah. So yeah. So everything will be fine. Yeah. So if you're very much interested in creating models, testing models, then you should, yeah, completely focus on ML engineer. But if it is an AI engineer, then you full stack, front end, back end, anything will do, because all are involved in an AI engineer. Those all are important for AI engineer jobs. Yeah.
yeah. Okay, ma'am.
Okay. Okay. Okay.
Hi,
I shall
ma'am. I'm
continue.
Ankita.
Yeah.
Ma'am, so if I want to learn any tools or any testing tools like that, if I want to learn any tools, what type of website you will suggest, ma'am?
Oh,
Or
testing tools.
any yeah.
I have to search for this. I'm not into testing.
Not only for testing, ma'am. If any tools I want to learn, if I want to learn AI tools, or else if I want to learn a cyber security tool, if I want any type of tools I want to learn, means what type of website I can go through, and I
Maybe
have doubt.
I search and I send to you later.
Okay, ma'am. Okay, ma'am.
Yeah. Okay. Thank you.
Also, to improve my communication skills and to know more vocabularies, where can I find that, ma'am?
Okay, so there are many advertisements, and I haven't used in social media for the AI tools that help you with your language fluency. I think that is a better option. I don't have a name for a particular tool, but AI tool will be useful because you don't feel embarrassed when you ask it again and again. It beautifully corrects your mistakes. I think search for any AI tool that can improve your communication skill. Yeah, I mean English language fluency. Yeah,
Thank you, ma'am.
yeah. Once you get hold of the language, or if you know to communicate in whatever, there may be grammatical mistakes. Fine, that is a fine tuning your language, but you should, if you are prepared well, if you are thorough in your subject, if you know every nitty gritty things in your subject, it gives you the confidence to communicate. That's why preparation is the best way to communicate. Prepare well, you can communicate well. Yeah. Thank you. Shall I continue?
Yes, ma'am.
Mm. Can you see my slide?
Yeah, ma'am. We are able to see.
Okay. So educational background, yeah, of course, your educational background is more than sufficient, computer science engineering, and you should have math foundation, linear algebra, calculus, and probability. Of course, you have learned from your higher secondary. And technical skills, you should have proficiency in C++ and Python. Yeah. And we mostly use Python, C++, of course, and mostly Python because it's easier to code. Yeah. And the frameworks is the robot operating system. There are two versions, ROS 1 and ROS 2. So if you're familiar, it will be easier. And simulators or visualization tools. So if you don't have a real robot, if you want to visualize how the robot works in a simulation, you need a simulator. The most commonly used simulators are Gazebo, and the latest one is iSexim. And you should have some core concepts, understanding of core concepts, kinematics, dynamics, simultaneous localization and mapping, path planning, embedded systems. So today we are going to concentrate on robot operating system. The core concepts you can just do ChatGPT or whatever, what is kinematics, dynamics. You can have just a basic understanding because there are libraries that already do the simultaneous localization and the mapping, path planning. There are multiple algorithms and implemented. Okay, so now we are going to focus on robot operating system. And if you're curious about what is kinematics and dynamics, SLAM I will cover later. Kinematics and dynamics. Kinematics is a study of motion without considering forces. Dynamics is a study of motion considering the forces. Okay, so to understand, for kinematics example, if I move the motors by angle, if there is a robot arm, there is a motor that moves the arm. If I move the motor by angle θ1, θ2, where does the hand end up? If you want to calculate, I need some formula. These physical formulas are provided by kinematics. So this is not about forces. If I move, how much it will move. That's it. Okay. Dynamics. If I apply some force, how fast the arm will swing. So these physical for mathematical formulas are used in implementing or providing physical motion to the robot. Okay. So knowledge of basic knowledge of kinematics and dynamics will be helpful. So we go into robot operating system. What is a robot? A robot is a machine that can sense its environment. How it senses the environment using sensors, cameras, lidars, and many other sensors, etc. Then it has to process the information using algorithms. So what does it require? It requires a CPU. It requires an operating system inside it. The ROS is primarily developed for Ubuntu. So I mean Linux. So you need an understanding of Linux. Okay. The process the information using CPU. It has a CPU, and algorithms or AI algorithms are running inside the AI models are running inside the CPU. Then after processing the information, what the robot should do? It should act physically to perform tasks like navigating, picking an object, etc. So what are some common robots, autonomous robots, industrial robots, drones, yeah? Anything that that is an autonomous system may be considered as a robot that can sense, process, and act can be considered as a robot. Okay, so what are the difficulties in robotics? Because robots must integrate sensors, yeah, the lidars. What is a lidar? First of all, I say the sensors. The sensors should the robot doesn't have an eye, so it should sense the environment. It should see the environment. So to see the environment, I need a map of the environment. So how the map is generated? From the sensor. The lidar sensor, for example, is a sensor that sense light waves, okay, laser waves in 360 degrees. It sends a 360-degree laser wave, and from the light waves travel and meet an object, and it reflects back. If there is an object, it reflects back. If there is no object, it goes on. Okay. So from this, using the speed of light, it calculates the distance of the object from its center. So using the output of the lidar sensor will be a map. It can be a 3D cloud. I mean, yeah, point cloud, 3D point cloud, where if there is an object, there will be some value intensity. If there is no object, it is empty. Or it's for a 2D map. 2D map, it is called an occupancy grid. You can imagine a 2D map as a black and white map. Sorry, I don't have any images, as it is too short. The time is too short. I am unable to present you with multiple images. You can imagine an occupancy grid as a black and white map. If it is white, there is no object. If it is black, there is an object. That's it. So lidar. So this map is used by the robot to sense its environment. So sensors can be lidar, camera, IMU to inertial measurement unit. This is a sensor to measure the acceleration, rotation, velocity of the robot. Okay, so there are some sensors. Okay, and CPU is the central processing unit, a small computer that can run algorithms. It can process input commands and calculate the movements of the calculate movements. Okay, and the actuators. What are actuators? These are the motors, the pistons, or the hydraulic drives that physically move the robot's joints. So a robot is a connection of just joints. Okay, so there is a CPU running. There are sensors. Sensors give information. The algorithm running in the CPU takes the sensor as information and understand, and it sends commands to the actuators how far the motor in the arm should move, how far the wheel in the robot or the robot's legs should move. Okay, so these are, you can just imagine a robot now with the sensors, CPU, and actuators. These must communicate with each other for the robot to function. Yeah, the sensors should sense the data to the CPU. CPU should process and send the messages, control commands to the actuators. They all should communicate. So what is the problem here? Diversity of hardware, complex software, and real-time operation. They should be quick enough. Okay, if there is a block before the robot, it should quickly stop. It should immediately take action. There shouldn't be any delay. And the systems are distributed. Sensor, a driver is a separate process. The lidar sensor driver is a separate process. The CPUs, there are algorithms running in the CPU or separate processes. All are distributed. The distributed system. A robot is a distributed system. So these are some difficulties. So what is ROS? It is not a traditional operating system. Then what is ROS? Robot Operating System, what is it? It is an open source middleware framework used to write complex robot software. Okay, so used to write complex robot software in an easy way. It makes our job very easy, make the communication very easy. Where does it sit? It sits exactly between your computer's operating system and the robot's hardware. It acts as a communication and messaging layer between your computer and the robot's hardware. That's it. So what ROS provides? It provides a communication mechanism. It provides tools. What are the tools? Some GUI and command line tools. Command line, the command line commands, okay. The GUI, graphic user interface, for you can visualize the robot models, how the robot is moving, okay. And there are it provides debugging tools, it provides logging tools, and also provides tools to run robots in simulators. So if a robot is running in a simulator, I want to talk to the robot running in a simulator like Gazebo or Isaac Sim, it provides a tool. It provides a bridge tool so that I can talk with the robot in the simulator through a common interface. A communication is common, so everyone should understand the language. So it provides a common language, okay? And it also provides libraries. So as I previously said, a robot has to prepare a map if it has to move. Then it has to, if I say go to X comma Y, what does the robot need to know? The robot needs to know where the robot is in the map, in which location the robot is in the map, and where is the location, now where is the goal location, and it should plan a path. It needs a plan, an algorithm to plan a path that goes through this map in the white locations, in the sense. You know, I already said the LiDAR gives me the output of a LiDAR is an occupancy grid. Using this map, I know where are the blockages and where is a free path. So through the free path, it has to plan. There should be an algorithm that plans a shortest path to the goal. And of course, perception. This is after AI came into robotics. It can sense through camera images. I can use an AI model to identify an object, to label an object. Okay, the object using the perception modules. It can if the robot has a camera and the image goes to a algorithm. Classification algorithm or labeling algorithm that can label, okay, the robot has a laptop before it at location, so and so, it has a mouse at location, so and so. So perception, so understanding of its environment from camera images. This is the latest. Okay, so we will more focus on navigation example yeah. Okay, so it provides some libraries. So you don't have to write the algorithm. You just need to know what is kinematics, what is dynamics. That's it. So they already have implemented all the algorithms. You have to just launch the ROS2 program for navigation or ROS2 program for motion planning. That's it. And as it provides a common language, my program can speak in the same messages to those libraries. It makes my job easy. And package management. Of course, if I'm writing an application, it should provide a way how to package my all the files and package management. And open source device drivers. Okay, so this is very interesting. So it provides open source device drivers for cameras, LiDARs, and IMU, robotic arms, etc. So if I'm buying a robotic arm, or if I'm buying a IMU sensor, or if I'm buying a LiDAR sensor that is ROS compatible, what it can do, the driver can translate the ROS sensor output and actuator and the ROS sensor output into standardized ROS messages and services. So if you are buying a ROS compatible robot, they provide a document, okay, that lists all the ROS2 messages, ROS2 services which we are going to see soon, ROS2 actions, ROS2 topics, okay, that the robot can understand, and what the robot expects as input and what the robot will give as output, all in the format of the ROS messages. Okay. So now, what ROS provides? Before ROS, what is the problem? Every robot software is custom. Every vendor will have their own software. Okay, difficult to integrate. I cannot integrate. If I buy one robot from one company and another robot from another company, it is hard to make the two robots to communicate to each other. Okay, so difficulty in integration. But if both are ROS2 compatible, now they can integrate. Little code, so I can now I can write a code. If I have a ROS2 custom code, I can use this code for any ROS2 compatible robot or a sensor or a ROS2 compatible sensor. Okay, so ROS introduced. What did ROS do? It just introduced standard interfaces, reusable software, faster development, and there is a wide community support as it is open source. So how it is the architecture? It is a distributed architecture. So now see, we saw here, there are some okay, the drivers for camera, driver for LiDAR, driver for IMU. Okay, what are this? If I ROS2 compatible driver, if I run it, it runs as a ROS2 node. Okay, these are separate programs. Okay. These are separate ROS2 compatible programs that can speak in ROS2 language and can understand ROS2 messages. Okay, so these are distributed. Okay, so ROS allows multiple processes running independently to communicate with each other. Okay, it allows multiple processes to run independently. Okay, in a single so run independently in a single thread or multiple thread. Okay, example, if you have a ROS2 compatible camera and when you launch, there is a ROS2 node. Okay, what does this do? It will send all the camera feed as a ROS2 message. Okay, so ROS2 message usually will have a header and a body. Okay, so where can we find this ROS2 message structures? There is a, you can just search for ROS2 messages. You have a list of message structures supported by ROS2. So anyone who develops a driver or ROS2 compatible should follow the message structure. And even if you buy a ROS2 compatible robot, and if they have custom messages not defined by the standard, okay, they will provide the structure, ROS2 message structure. The structure will follow exactly the ROS2, and we can use those messages to communicate with the robot. Okay. So camera node, example, coming back, camera node, navigation node, motor node. So what is a node? So now these all can communicate together because all know the ROS2 messages. So what are ROS2 nodes? These are executable processes. So let's see. The Python code, please look into the first line, import RCLPy. So in Python, so the ROS provides all the libraries necessary for you to implement. So this is a simple program. I'm importing the RCLPy library, and I'm importing a node. I'm creating a class that inherits the node. Okay, so we are not going into the node now. The class now. So it is I'm creating a class with just inheriting the node class. Okay, now please look into the main function. So I just initialize the ROS2. Okay, and I create an object for the class, which is you can see here, class minimal publisher. I create an object for the class. Then I just rclpy.spin. I give the object of the class. That's it. Okay. So this is spin the node. Okay, it will spin the node. Now, yeah, you're simple. You have written a ROS2 program, and when you run the program, you have launched a ROS2 node. It is an executable process. Okay, so if you use then, so we are going to see ROS2 topics, services, and actions. If you know how to implement a ROS2 topic and service, then you can write a ROS2 node which can accept images from another ROS2 node. Yeah, and do whatever processing as you need. Okay, so what is a ROS node? It is an executable process. So providing this framework allows me to write modular programs, reusable programs, and easy to debug programs. Okay. And next one is ROS2 topics. What are topics? Do you know about the publish-subscribe model? In publish-subscribe model, there will be a publisher who publishes messages at some specific interval or as and when the input comes in. Publisher will always publishing messages. And if I need the message, I have to subscribe for the message so I can receive the message. Okay. So subscriber, usually I subscribe for the message, that particular topic. And I usually, when you subscribe, you give a callback function. So whenever the message is available, my callback function will be executed. This is how this is normally implemented. The same way, ROS2 has also implemented a publish subscribe model. Okay, so how to see? You can see here. You can see in the class publisher, you're just creating a publisher. It's easy, just create publisher. Okay, this is a method of the node. And I'm creating a timer of 0.5 seconds, and I'm giving a callback function. So what does it do? When I create a timer, it will call the timer callback every 0.5 seconds. So the timer callback function, it is sending a message, so message string. Okay, so message, the string is a string message format given by ROS2 library. Okay, so you have to whenever I say a message, it has a structure, it has to be imported. Only if I import the message structure, I can use it in my actions or services or topics, whatever. Okay, we are going to see actions and services. So every message, the library provides all the message structures. So you have to import the message. So after you message, so this object only has a data field, whereas hello world, and it is this callback will publish. Publisher is the publisher object we created here, and I publish the message. That's it. So when I run this one, when I spin, I create the object, and when I spin, what happens? Every 0.5 seconds, I publish the message hello world. To who? To whoever subscribes for this message. I don't care who gets it. I just publish. Whoever subscribes for this message, what is the name of the message? The name of the message is, topic, okay? I name the message as topic, okay? So whoever subscribes for this message will receive the message. Okay, for example, sensor messages, camera info. This is just to make you feel how this image is to make you feel how a message format looks like. You can Google it. You will find all the messages, standard messages provided by ROS. Okay. So what are ROS2 messages? Topics carry messages in the ROS2 topics. Topics has a name. Message has a message is different. Okay, message type is different. Okay, topics carry messages. What are messages? These are the primary data structures used by ROS programs to exchange information on the network. These are some common message types: sensor messages, geometry messages, name messages. And most important message you will often hear in robotics is command velocity. This is sent by remember I told you ROS2 not only provide the messaging, it also provides some libraries. So one of the module is the nav2 module, which allows the robot to navigate. I can send a goal location. If I send a goal location to the navigation module, it sends commands to the robot to move to the goal location. So what command does it send? This is the command velocity. A ROS2 compatible robot will understand the message command velocity. So what is the velocity? Velocity has a speed and a direction. So the robot will move in the same speed in the direction specified in the command velocity message data. Okay. So this is a figure that shows to get a feel of how the message definition looks like in the website. Okay. Then we go for ROS2 services. What are ROS2 services? This is a request by response communication. Request by response communication, just like you write API services, REST API. There is a server, you have a backend service, you request, you send a HTTP post request or GET request, and you get a response, right? That is in HTTP. This is a similar implementation in ROS2 services using ROS2's base protocol, okay? So you can see so I can send a request. So I'm just creating a class, inheriting the node. I have to say, I also have to import the messages format. Okay, this is okay. So this is a custom message because there is nothing. So this is a service to, if I give two numbers, it will add and give me the response. This is not some a standard ROS2 service. So there is no message for it. So I have to, when there is a no standard message, if the message is a custom message, then I have to write a custom message format, put the file in the directory as ROS2 says. It says if you want to write a custom message, write the message in this format in a text file and put it here. Okay, and the folder I have to put, if I put it in the folder, and I can import it here. Okay, so now the message format is add to ins. Okay, I'm creating a service. There is a callback which will call the server. Okay, so this is a service node. So I register a service. The name is added to ints, and I also specify what should be the requesting message type. Okay. Sorry, I also specify the whenever someone sent a request to this service, I should execute this callback. What the callback does, it will take the two numbers from the request, add it, create a sum, and just return it. Okay, this is simple. You don't need to by heart how these the structure and syntax of ROS2 There are a variety of examples for services, for custom message creation. Just go to the tutorial, implement it. There is no by hearting from now on. Just implement it. Whatever you study, you just try it. How does it work? Let you try it in your PC. So the more you do it practically, the more you learn, the more you, yeah. So that's the only way to grow, yeah. So you create a, so I just then in the main function, just initialize, I create an object for the class, then I just call the spin function given to the minimal service. That's it. I execute it. A service is ready. This is a separate process, the modular separate process. It just adds two numbers, but it is a single process running somewhere where anybody who joins the ROS2 network, any client can call the service, give two numbers, and get the response. This is how a ROS2 service works. So, sorry. So how usually, so a client, you can write it as a program, or you can just use a command line, CLI command. So the ROS2 also provides some commands for easy testing. When you're implementing, you have to implement as a program. But if you're just testing, you can just use a command line, ROS2, to check if this one works. ROS2, you can just service, this is the command syntax, then call, these are syntax, the words you have to write as such, then add to ints. You have to see the naming convention here in Python. When you write, it is camel case, and you have to here underscore. Okay, you have to write the same, and you call the function name is add to ints. The service name is add to ints. Okay, and you have to give the a equal to 5. This is how you have to call the service from a command line. You can also write a client program to call the service. So usually where it will be used, if a robot has a service that gives me the battery level, I can call the service, okay, to receive the battery level of the robot. So I can write, so you can, you have a web UI that displays, you have 5 robots in the, 5 robots in a room, and you are developing a web UI that shows you the 5 robots and its battery level. How will you do? You just, your backend should ask every few seconds. Your backend should send a request to this battery service, get the response back, and display on the UI. That's it. Now we go for ROS2 actions. What are ROS2 actions? They are similar to ROS2 services, but they are used for long-running tasks. For example, if I want to ask if I'm asking the robot to navigate to a goal location, this is a simple service, right? Just like add two numbers, give the result. Yeah, fine. But this one is a long-running action. So what do I need? I need to know if the robot is moving towards its goal. So I may require some feedback from the robot. Yeah, I have started. I'm at this location. I'm at the second location. I'm at this XY coordinate. Oh, I have finally reached the goal. So this is a long running task where I need the immediate response, whether this can be executed, and the final result. I have completed the action and also a feedback callback to get the progress of the result. So this is a long running task. The robot accept the goal, it reports the progress, and it also allows. So if I want to cancel the long running task, I can cancel it, because this is important, okay, in navigation. So I don't have the program for ROS action. Just you can just if you're using, just you can copy and paste. Okay, just what is the difference between a ROS service and a ROS action? For a ROS action, you have to set an immediate response callback. It will immediately reply. If you have used JavaScript, you may have heard about a promise, that is a future. Yeah, this is a similar implementation. It will return a future. So this is an immediate response. Okay, then you have to also set the final result callback. This will be called when the action is completed, and a feedback callback. This will be called whenever the action achieves a simple milestone. Okay, next milestone. Okay, however, the action is implemented when it is supposed to send the feedback. So if you have these callbacks, you will get the immediate response, you will get the feedback, and also you will get the final result. Based on that, you can display the results on front end. Yeah. So to summarize, ROS2, the important concepts in ROS2 is nodes. It's a executable process. You can just write a simple Python code to launch a process, launch a node. You can have topics. So if the publish is, for example, if the robot is constantly publishing its location, where is XY coordinate, I want to get it, I want to retrieve it and show it on my web UI. What I have to do, I should know which topic the robot is publishing its current location. Then I should write a program to subscribe for this topic. Then whenever I receive, I have to send it back to front end, or I should allow the front end using some HTTP streaming or WebSocket or whatever. But if you want the front end to take it from the backend, then you have to timer using a timing recall. Every few seconds you have to call the backend. The backend will already subscribe to the ROS message and has the robot's current location, and it will send you the robot's location. Now you can also give a beautiful animation and show the robot is moving in the web UI. Okay, this is how as a front-end engineer, how you can work in robotics. Okay, so then messages, all the messages are standardized. You can also create custom messages for everything, for a publish subscribe, or for a request response, or for an action. Every message you should write a file and you have to import it. Okay, you should write a file and import it. Every message should have a structure. Response message, final result, feedback message, every message, it has if it is a standard message, it already has a file. If it is a custom message, you have to create a file and you have to import it. Okay. So what is Orbis? This is a visualization tool provided by ROS2. It is a 3D interface that lets developers see what a robot is seeing and planning. Okay. So you can see the model of a robot. What are all the things you can see here? You can display the data from cameras, lidars, radars. Okay, what are they? They can be point clouds, they can be depth maps, how deep. Okay, and laser scans. Okay, so you can visualize the data from the sensors. You can see the robot model. So you can see a robot model file is named URDF, Universal Robot Description Format. When you buy a robot, the manufacturer should provide you a URDF file. Okay, this file is a 3D model of the robot. Okay, so it will have all the parts. Where is the location of the part? Where is the joint located? And everything. Okay. So this is a 3D model. So when I give the 3D model, any visualizer can draw the robot. So it knows if you say the center of the robot is 0, 0, the 3D model will say there is an arm of this shape at location 5, 5. There is a rectangle box at 6, 6. So this is a URDF file. Okay. And how it draws, it also say there is an arm at location 5.5, and this is the image of the file, and you have to also provide an image, PNG image or whatever image it requires. That's why it can draw here. Okay, so the URDF file just have the location of everything. Okay, if the center of the robot is taken as 0, 0, yeah, it will have the coordinates of each part, and it will also have how to draw. If it is a draw, it may have some additional texture or image files that are. So now if you give this file to a 3D visualizer, it can render the image as per the URDF, as per the description. That's it. Okay. So another important concept I didn't include in these slides is transformation. Transformation is every frame of, you should know what is a frame of reference. Okay, for if you say a robot's frame of reference, if you say robot's frame of reference, it means that the center position of the robot is taken as the origin 0, 0, and everything will be represented from this location. So if the sensor is to the right, then it will be like a positive. It's the right 5, 5. Okay, so everything is represented in this reference. Okay, if you say the maps reference, frame of reference, so this is a big map. Okay, so its origin may be here 0, 0. So every object here will be represented based on this origin. If it is located 10, 10, based on the robot's map, in the maps reference, the robot is at the location 10, 10. But in the robot's frame of reference, robot is at 0, 0. Okay, I mean, sorry, not 0, 0. If the center is 0, 0, it is -5, -5 or something. Okay, so there are different frames of reference. Robots frame of reference, maps frame of reference, these are static, they don't change. There are also dynamic frames of reference. So for example, while the robot is moving, okay, compared to the initial position where the robot started, if you consider the initial position where the robot started as this frame of reference will be continuously moving. So there is also a dynamic frame of, dynamic, that they will be changing. Okay, so sorry, frame of reference doesn't change. Okay, the transformations change. Okay, so now what are the transformations? What are transformations? Transformations say or used to, they are just like you may have studied in where graphics, where somewhere the translation, rotation, whatever, translation matrix, rotation matrix, okay, that change from one frame of reference to another frame of reference. Okay, so the transformations or the mathematical operations or the matrices, matrix multiplications applied to change an object's position from one frame of reference to another frame of reference. Okay, so if I want to say move the robot to, for example, LiDAR has its own frame of reference. If I want to convert it into robot's frame of reference, it will be represented from robot's origin, where is the LiDAR. So what is the transformation I should apply to change the LiDAR from its frame of reference to the robot's frame of reference? Okay, what matrix multiplication I should do? Okay, so this is a transformation transformation. Okay, okay, so this is a concept you need to know. There is two kinds of transformation: static transformation and dynamic transformation. A static transformation, the transformations do not change, but dynamic transformations change as the robot moves. Some transformations change. Okay, I'm not going into deep because I skipped the topic from here, and this is basic concept I added here. Okay, and now navigation and mapping. You can also visualize the maps, cost maps, and planned navigation paths. Okay, that's you can. If you want to know what is a cost map is a map whose value is between 0 and 255. Lower values say lower values indicate that that's a free space. Higher values indicate that there is a blockage. So the cost map is a byproduct of the sensors, lidar sensor, and this is used in path planning to identify if there is a blockage or if it is a free space for the robot to move. Okay, these are cost maps. Okay, we can visualize everything. Okay, so there are tutorials, separate ROS tutorials. You can look into it to have a feel of it. And I have provided a link, watch ROS 2, NAVE 2 with ROS. You can use it. Okay. Finally, the command line tools. So it provides some commands to, if I run few ROS 2 nodes, and I take another computer, I joined in the same network, everything should be in the same network. Okay? So I type ROS2 topic list, then it lists all the topics available, published. ROS2 node list all the nodes available in the network, ROS2 network. ROS2 service list all the services available in the list. ROS2 topic echo, it will list if you have a specific topic, you want to see the topics information, what is the message sent in this topic, then ROS2 topic echo. Okay, there is a topic name. Under the topic name, a message will be sent. If you want to see the information about the topic, this comments. This is just an introductory. There are many comments. I just say to have. I just bring the things that give a feel of what is ROS. That's it. Okay. So we are reaching finally. Actually, I have to provide a video here due to shortage of time. I don't have it. Okay, how a robotic system works with ROS. Okay, now we know about the ROS. So what is it? It is a middleware framework that makes my job easy. That's it, right? So if all the components are ROS2 enabled, they can talk to each other. Okay. So now we saw bits and pieces. Now let's chain them together so that we understand it better. So here you can see camera components of a robot. There is a camera, lidar, inertial measurement unit. This is nothing but some sensors that provide the output will be the velocity, acceleration, position of the robot. Okay. Angular, acceleration, and okay. Navigation is a ROS2 module. As we know, ROS2 provides a module for a robot to navigate. That's the NAVE2 module. So camera is ROS2 enabled. LiDAR is now ROS2 enabled. IM is ROS2 enabled. We have ROS2. Okay. ROS2 enable the drivers, and they send messages in ROS2. Okay. The navigation module, I have a navigation module, which is a library provided by ROS. I can launch in any system. If the robot's CPU is powerful enough, I can run the navigation module inside the robot, or I can run this navigation module outside of the robot in another computer system, because all that can communicate with each other. Where I run the that's why it's called distributed. Where I run this program doesn't matter, yeah, because they can all communicate within the ROS2 network. Okay. Navigation module, I can either run in the robot or in a separate PC, and the motor controller. So the motor controller is also ROS2 compliant. So it's a ROS2 node. This is a ROS2 node. Okay. We don't have to worry about all this. When you buy a robot, the manufacturer already provide you with the interface document that provides all the standard messages sent by the camera, lidar, IMU, motor controller, whatever. Okay. So now navigation is our open source module, which we run it. Okay. This or the 1, 2, 3, 4, or from the manufacturer, the navigation is how we run, how we make the robot to run. Okay. Now, if the robot has to move, okay, what does it need? First, what they usually do, they move the robot. If I want to send a command to make a robot to move from one location to another location, the robot should have a map of the place. So what they first do, they first navigate the robot through the entire room or entire hall where the robot is supposed to work. Okay. and they run the algorithm, mapping algorithm, that is called SLAM. There are many mapping algorithms. There are a few mapping algorithms. One of the SLAM, simultaneous localization, and what is it? SLAM. Mapping and mapping. Okay, they run an algorithm. Okay, so what this algorithm does? It takes the output of the lidar sensor and produce a map. This is occupancy grid, the two-dimensional map, or if it is 3D, it is a point cloud. Okay, occupancy grid is, you imagine it is a black and white image where the white represents that is a free space, black represents that is a blockage. Okay, so I have a map. So initially the robot has a map. Okay, so now if the robot has to move, what I have to do, first of all, I have to on the robot. Okay, and now everything is ready. All the ROS2 nodes for the sensors are ready to send messages. The lidar will be sending its current position. Okay, so now I should have a localization module in the robot which can localize the robot. Okay, this localization robot, where it is available, this is provided by the navigation module. Okay, so the robot can localize. Localize means where am I in the current map? I have a map. Where am I in the current map? How does it do it? It uses some computer vision matching algorithms to match the current LiDAR's input with the already available map data. It matches, and as the robot moves, it doesn't localize at a stretch. As the robot starts moving, it uses a matching algorithm to find where in the map the robot is currently standing. Okay, so this is localization. Okay, now first the robot should know where it is. So there is a localization algorithm to identify where the robot is. Okay, I know the current location. Okay, now the navigation module knows the current location. So now the planner, what does the planner algorithm does? If I give a goal location to the planner, it will find the shortest path between the robot's current location to the goal location, taking the free path. No, okay, considering all the, so this may be implemented using an A-star path planning algorithm. Okay, this is already implemented in the navigation module. And the controller, what the controller does, the planner, after making a plan, gives the plan to the controller. What does the controller do? The controller is the actual software that converts according to the plan. So this is like a local plan, I mean locally. So to make the next step, okay, to make the next step, how much of control should how much I should move the wheel, how much if the robot is picking the object, how much I should move the hand. This is decided by the controller. So the controller takes the planner's path and sends finally the velocity commands. You see command velocity commands to the motors. Okay, I mean how much so the controller sends the control commands to the motors or to the wheels. Okay, how much the robot should move along the path, not away from the path, along the path. Okay, so this is how a robot navigates. Okay, now how ROS2 plays here, okay, and how we come inside it, inside this one. So now you design a beautiful web UI, and this is like a one step ahead. This requires some AI model to understand, LLM to understand, navigate to room B. So we will skip for this now. So we say navigate to 100, 105. Okay. So already we skip the AI part. Okay. Navigate to 105, 105 or some location. So who gives the goal? From the web UI, the user gives the goal. In the web UI, you also display the map. Okay. And the user clicks a location in the map and you convert into a coordinate and you send the navigate to the backend. Navigate to 105, 105 to the backend. Now, how it's easy? Because the sensor is ROS2, camera is ROS enabled, lidar is ROS enabled, IMU is ROS enabled. So, what is the navigation module? The planner needs the lidar's map, the IMU's position, velocity, and okay, whatever the input. Now, how can it get? through ROS2. Already they are ROS2 compatible. Through ROS2 messages, I get the LIDAR's point cloud, IMU's acceleration, all those values, everything, and I use the navigation module uses the ROS2 messages to localize, plan. It sends the planner, it sends the plan to the controller. The controller again, it is a ROS2 enabled. It sends the final control commands to the motors through ROS2. Motors can understand. Okay, they can. Okay, so it can move. Okay. So now what I have to do, everything is ROS2 compatible. What I have to do, I have to just write a backend program that is a ROS2 node that can send. And so already we know the navigation is implemented as an action. So we have to just write a backend program that is a action client, okay, that sends that calls the navigation module with the goal position, and you have to set a callback for immediate response or the feedback response or the action completed response. That's it. So if you want to display the feedback to the front end, also you can relay the feedback intermediate positions of the robot, or when the robot finally reached, you can display the robot reached beautifully in the web UI from where to where. Okay. So I think now ROS2 makes the job very, very easy. So that's it. The final is ROS1 versus ROS2. Initially, they started with ROS1 version, and then they went for ROS2. ROS1 had limitations. It has limited real-time support. It has security limitations and multi-robot scaling issues. And ROS2 came with all those features. So you may be wondering, what is the protocol they all communicate? How they communicate, okay? So the ROS2, they use a DDS middleware. They need a middleware. The underlying protocol is UDP. Okay. So how they all subscribe to your topic? It is a UDP multicast. When I do a UDP, the underlying is UDP multicast. Everyone who subscribes to that multicast group can receive the message as simple as that. So the basic underlying protocol used is the UDP multicast to discover all the nodes in the network. And the DDS middleware provides some security. There is a security limitation in ROS1. So the DDS middleware supports some encryption, authentication, so that just like that, anyone cannot run a ROS node and crash our system. So it provides some security and better reliability. Okay, and multi-robot, you can have multiple robots. There are some configurations. So you can name a network like ROS, some ROS node. I forget the command. So ROS something, a number. Okay. When you run a command, before running a command, you have to, before executing a program, you just say address. For example, I forget the command. Assume that the command is ROS network. I say ROS network 1. I type the command CLI ROS network 1. Then I launch the program. And in another computer, I type ROS network 2 and launch another program. In another computer, I type ROS network 1, another program. So only the programs in ROS network 1 can communicate with each other. The program which I launched in ROS network 2, it cannot communicate with the other network. So I can have multiple robots just by giving a number, a command with a number. Before running the program, I just type a command with a number. The number uniquely identifies one network. So this one solves the multi-robot scaling issues. I can have hundreds of robots, separate robots running with each other. So yeah. So the scaling is a problem is solved by ROS2. Underlying, what does it do? It just creates a different UDP multicast group that is multicasting to a different port. That's it. So yeah, this is so the ROS2 is the late. Yeah. So there are multiple distributions in ROS2. So this is supposed to be ROS2 distributions. This is taken from this website. So they have multiple distributions. So one distribution may have additional features. They add additional features, and one distribution of ROS2 may work for one Ubuntu. So when Ubuntu updates its operating system, also ROS2 has also update its version. So one version, the distributions are more tied to some operating system Ubuntu versions, and so on. Okay, and so these are there are many versions. They are outdated. Okay, these are the latest versions, ROS2 versions. And this is a really simple issue, because you can find many applications in GitLab using ROS2, but they may be using an outdated ROS2 version or something, but still there is some support. Yeah. Okay, now what's next? Just you learn ROS2. I have just given an introduction, let you taste what is ROS2. That's it. There are more and more. Yeah. So if you have any questions, you can ask me, and thank you.
Thank you, Dr. Shamsad ma'am. Students, you can.
Hi, ma'am. This is Hari. I have a question, ma'am.
Yeah.
Yeah, ma'am. So when you talk about ROS, I have an idea of building a drone. So the drone is for capturing the people who are buried under the buildings when it collapsed. Okay, so it's like a drone. When I talk with my EC domain professor, and he was like, we can build the drone, we can have the this kind of drone and all those. So when you talk about ROS, I have interest on it. How come ROS can be implemented in drone, whether it is possible? Because in robot it is possible that it has arms, it has wheels, so it can function like ours is a platform that allow different software components of a robot to communicate, right? Is it possible that it always can be implemented in a drone, ma'am?
Yes, if they support ROS, if they support, if they support ROS2. For example, there are PX4 drones. They provide ROS2 support.
Yeah, how come ROs will support communication between two drones, whether it will allow to communicate between first, like we can have an example of drone 1 and to drone 2, whether it is possible that ROs help to communicate between these two drones?
Communication between these two drones.
Yeah.
Okay, so this was a difficulty in ROS1. ROS1 cannot be installed in small microcontrollers. Now the ROS2, there is a micro ROS version that can be installed in the CPUs in drones. Okay, small microcontrollers in drones. Okay. So with
Okay.
this, an example is PX4 drone that has successfully implemented ROS2, the micro ROS in drone. Okay, so the ROS2 communication with the drone is possible if the drone supports it. And I mean, these are the core developers who developed, so it should be possible from, for example, DJ or some DJ drones also support ROS2 communication. And your next question is what? Your next question is whether how can a drone communicate with another drone? Okay, if they both are ROS2 enabled, they can, if they can understand the message, they can communicate with each other. So far, our experience is only with the centralized communication. So there will be a centralized server that will be talking to the drone 1, that will be taking the current information from drone 1, drone 2, drone 3. And process it. And for example, if there is a drone swarm, okay, so the drones shouldn't hit with each other. There is a central thingy that collects the drone's current position from all the drones. And then from the central thingy, the central service decides, the centralized process is the one that sends the commands to the drone to fly. So they decide if they are together, close to each other, and if they are close to each other, they calculate some location that is far away, and now send the centralized service sends to the other drone. So this is currently we have experience. If we have to, if the drone has to talk with another drone, yeah, it's still possible. It's not impossible, but we haven't tried it. Yeah. So in that case, the drone should have an embedded PC, onboard PC in it, and you should run the ROS2 node inside the,
Okay,
yeah,
so it
and should
means
have a
how to select the
powerful
drone that will
communication,
support
Wi-Fi
all these.
communication. Yeah, there should be a powerful communication link.
Okay,
Yeah, the
okay, ma'am.
communication bandwidth. Yeah. So it's possible, as long as yeah. For that, the drone should have a embedded PC, and you should run the ROS2 node inside. Yeah, they can communicate with each other. That's easy. Okay. Any more
Yeah,
questions?
okay. Okay, ma'am. Thank you, ma'am.
Okay. And Harini, what you're saying is a complex problem. The drone flying is a separate, and if you want to detect some persons under collapse building, that requires separate AI modules. Currently, the challenge is running an AI model in a simple, I mean, in a microcontroller. So yeah, this is still under development. But if you have a centralized server running a model, and the drone is sending the images, it can then it detects the drone collapse or the people inside. So these are all separate processes. It doesn't completely link to drone. Drone is just you send a command, fly something, and the detection of the building collapse or separate modules, AI modules, that you can have a centralized server to detect them. That is a complete two different
Yeah, ma'am.
areas.
Like I have the
Yeah.
model that will detect person, but I
Okay.
have the complexity in building the drone, so that when it
Okay.
comes to the topic of ROS, so have curiosity of whether it can be integrated or it's
Oh, yeah,
different.
yeah, yeah.
So
It's
that's my
possible. Yeah, it's possible. It's possible.
yeah.
Yeah,
Okay,
yeah,
okay, ma'am.
yeah. So usually drones use mailing messages. You can also go for that. Yeah. Underlying is UDP. Yeah. Okay. Then any other questions?
Students, do you have any other questions? Vijay ma'am?
Yeah, ma'am. I think we can wind up. I think it will be
Okay.
almost 10 o'clock over there.
Yeah,
It's
Oh,
time
it's
to
too
cut
late
for
it's
ma'am.
fine.
already,
It's
and
fine.
then
It's fine. It's
Ma'am,
fine.
a
yeah.
small
Uh,
thank you message. Shall I
Thank you,
continue,
ma'am.
ma'am?
On
Vijay
behalf
ma'am?
of our department and institution, I would like to express a heartfelt thanks to our distinguished resource person from Singapore for delivering an insightful and inspiring session on robotics and operating system. Madam, your valuable guidance and real-world perspectives have been immensely beneficial to our students. We sincerely appreciate your time, effort, and contribution, ma'am. Thank you so much.
Thank
Vijay
you.
ma'am?
Thank you, everyone. Thank you, students. And thank you, Shamim, for this opportunity. And
2
thank you, all the
minutes.
staff. Yeah.
Excuse me, 2 minutes. Vijay ma'am, can I just a few words?
Sure, ma'am. Go ahead.
Yeah. And as we come really to close of the session, first I'd like to express my thanks to the Almighty, really, whose blessings, wisdom, and guidance this has enabled us to successfully organize this series. Our department is organizing the series for the betterment of our students, for their placement and for their career. Though it is a vacation period, daily we have a 6 to 7:30 series. And today it's a great privilege to have Dr. Samsad Beagum with us to have a talk on building a career in robotics. Actually, her session has opened new horizons, I think, ma'am, for our students. It is into an exciting world of robotics, and the clarity, the depth, and everything was the way she was presented was really, I think it is a very learning experience for all of us. And actually, speaking out, it was a very short notice. I just called her only yesterday night, around evening, I think, and requested her. In spite of all the submissions, she has a project submission deadline this Wednesday. She immediately accepted the invitation without hesitation and graciously made time for our students. Thank you so much, ma'am. Thank you so much. On behalf of our management, principal, and head of the department, Dr. Rajaguru sir, our faculty members and coordinates. And I really thank you for giving us your valuable time and sharing your expertise. Thank you, ma'am.
Thank
May
you.
be
Thank you,
blessed.
Shamim.
Thank you.
Yeah.
Thank you,
ma'am.
ma'am.
Thank you
Thank
so
you.
Thank you,
much.
Thank you.
Yeah.
everyone, and thank you, students, yeah, for your patience. Yeah. Thank you.
Thank you. Thank you, ma'am. Thank you.
Thank you.
Wish you all the best. Yeah.
Thank you, ma'am. Thank you.
Shamim ma'am, I'll end the call.
Yeah, ma'am. Thank you, ma'am.
Thank you
Thank you,
so much,
students.
ma'am.
Thank you
Yeah.
so much, ma'am. Thank you, ma'am. Thank you. Have a nice day, students. All the best.